In this presentation, we're going to look at digraphs and relations. So consider the problem. T is the set comprised of the sets A and B, A, B, and A, B, and C. R is a relation defined on T as follows: X or Y if X is a subset of Y, where X and Y are elements of T. Draw the relationship digraph of R on S and state whether or not R is reflexive, symmetric, or transitive. So what we're going to do is draw the digraph and go from there. So first off, we have the four vertices here. Now, it's very important to realize that we have four distinct vertices here for each of these subsets, for each of these sets. So this is vertex 1. This here is vertex 2. This here is vertex 3. And this here is vertex 4. And there we have them there. Now, R is a relation defined on T as follows: X or Y if X is a subset of Y. Just to be clear, that means subset. Now, consider first off, let's consider the example A. A is a subset of A and B, so we'll have an edge going from A to A and B. And also A is a subset of ABC, so it is going to have an edge going there. Also, A is a subset of itself, so there's going to be an edge going there like that leads back on A. And in fact, for every vertex, there's going to be such a loop. Okay, because every set is a subset of itself. Now, let's look at B here as well. B is a subset of A, B. So an arrow pointing in that direction. And B is a subset of A, B, and C. So again, an arrow pointing in that direction. A and B is a subset of A, B, and C. And that accounts for all the relations. I'm going to change the color a bit, actually, just to make it a bit more easier to look at. So I'm going to make the vertices green. So the next question is, are these relations reflexive? Well, in each case, we have to check out the following. Does X or X hold? For example, is something a subset of itself? And as I just stated there previously, that in all four cases, we have the set being a subset of itself. We have these arrows pointing back towards themselves. So yes, it is reflexive. So that's the first question done. Now the next question is it symmetric? Well, if it's symmetric, we would have initially X or Y, and symmetric if Y or X. Now let's consider what this means here. If X is a subset of Y, that it would symmetric if Y is a subset of X. Now in that case, that does not hold, because for example, A is a subset of B, or A is a subset of A and B, but A and B is not a subset of A, so it is not symmetric in this particular instance. So that is the second one. It's not symmetric. Lastly, we're asked to determine if it's transitive. So transitive works on the following basis. So we have X or Y and Y or Z for vertices X, Y, and Z. It is transitive if we could sort of say X or Z. Now, in this case, yes, it is transitive. Why would I say that? For example, A is a subset of ABC. But we can also say the following. A is a subset of ABC, or A is a subset of A and B, which itself is a subset of A, B, C. So it actually works on that basis as well. Just to be clear about that, letting A correspond to X, Y correspond to AB, and Z correspond to ABC. X is related to Y because X is a subset of Y, and furthermore, X is related to Z because X is a subset of Z. And that concludes our presentation.